So in your table groups, what I would like you to do on graph paper, using your inspirational straight edge and making everything nice and neat, I'd like you to plot these points here that I've given you, 0, 0, 4, 0, 3, 2, 0, 2. Then I want you to draw the quadrilateral using solid lines that has these 4 points as its vertices. And then your task as a group is to come up with the system of linear inequalities that has the quadrilateral as a solution region. Okay? So you're trying to figure out, there should be a pair in there, figuring out what inequality would give you that solution region, and then talk to each other, how did you find that system? That should take you about 5 minutes. Okay, Theo, you're up, dude. What'd you get?
Y is greater than or equal to 0, X is...
Oh, wait. Can I do this? Can I... Well, first of all, did you get this picture?
Yes.
Can I label these? Like, if we were to sort of extend these lines here, right? If I was going to extend these, can I label this one as, like, line segment number 1, line segment number 2, line segment number 3, and line segment number 4, so that we all know what we're talking about? Okay. Is that okay? Okay. So what'd you get for line segment number 1?
Number 1, I got y is less than or equal to negative 2x plus 8.
Yeah, y is less than or equal to negative 2x plus 8. How'd you get that?
Well, just from the 2 dots, you could find the slope
Sure.
quite easily.
Sure.
Rise and run. And then I continued the line on and saw that it intercepted the y-axis at 8.
Fair enough. Fair enough. Okay, good. Okay, what'd you get for equation number 2 as we're moving down the line segment number 2? Is that one there on the bottom there?
Y is greater than or equal to 0.
Y is greater than or equal to 0. Fair enough. How about number 3?
X is greater than or equal to 0.
X is greater than or equal to 0. Finally, number 4, what'd you get?
Y is less than or equal. Less than or equal to 2.
Absolutely. Okay, so ladies and gentlemen, this right here on the left hand or the right hand side, this describes the system that puts all the answers inside that region, that solution region. So any point you pick inside that region will do what to the system?
Answer this.
What do you mean answer it? What do you mean? Well, how do we know it will answer it? It'll be true. You'll have 4 true statements for each of those inequalities in your system, okay? All right, so we're going to take that and let's apply it here. Here's what I'd like you to do. So in your groups, can you give me a set of inequalities? This is like the second box here. Can you give me a set of inequalities that would describe the region here? Notice which lines are dashed and which lines are solid. That's what I'd like you to do right now. Here's what I'd like you to do. Can you guys tell me the equation for the green line there? What is the equation of that green line? What would it be? Yeah, go for it.
Y is greater than or equal to x minus 3.
No, I just want the equation of that line. What's the equation of the green line?
Is equal to
Y equals
x minus 3.
x minus 3. What's the slope of that line? The slope is 1, and the y-intercept is a negative 3. Good. Someone give me the equation of the red line. Yeah. What's the equation of the red line? Yes. Go ahead. Yep.
Y is equal to negative 2x plus 6.
Y equals negative 2x plus 6 because our slope, our intercept is at 6 and our slope is negative 2. What's the equation of the blue line? Yeah, what do you got?
I was just going to say,
Yeah.
well, since we're trying to find the solution region, shouldn't it be, can we have that inequality?
We're going to go with that. When I create the system, we're going to change them to inequalities. Yes.
Okay.
Yeah. So what's the equation for the blue line? What'd you get?
Blue line is x equals 1.
X equals 1. Very good. Okay. Now that we've identified all the lines that are in play here, then we have to do what you say exactly. We have to define our regions and define our system, right? So here we go. So the system is, so for my green line there, I want everything that's above that green line, right? So then it should be y is greater than or equal to x minus 3. So far, so good? Yeah, okay. I want everything below my red line, my red dashed line. So it should be that y is less than, strictly less than negative 2x plus a 6. Agreed?
Yep.
And then I want everything to the right of x equals 1. So I want x is greater than or equal to a positive 1. That represents my system for the region. What do you guys think? Who come up with the same thing? Hands up. Let the record show that almost everyone in the entire room is explaining with their hands up. Good, okay. Okay, try this one on your own. Here we go. How do you explain this region right here? Go ahead, write it down. So what'd you do first, dude?
So So I figured out that the center is 0, 0.
The center is at 0, 0. I agree with that. Yep.
And the radius is 4.
And the radius is 4 units. Yep, I agree with that.
And it's a solid line, so it's going to be equal to.
Yep.
So I got x squared plus y squared is greater than or equal to 16.
Greater than or equal to 16. So wait, where's the 16 coming from?
Radius squared.
Radius squared. Now, how did you choose greater than or equal to? What gave it away?
Well, I tested 0, 0.
Yeah, you could just test 0, 0, right? 0 squared plus 0, 0. Is that greater than or equal to 16? No. That is not true. This is a false statement, right? And we always want true statements, so you'd shade the outside, right? So 0, 0, not part of the system, solution system, so we go outside, right? Okay.
Should we do graphing calculator first?
Yep, go ahead. Graphing calculator, that's fine. So we just came up with some, so here's what we did. Let T equal table and C equal chair. Okay, and we came up with this. We came up with 1.5 hours to make a table for the assembly, plus, what was it? 1 hour to make a table in the finishing center, and we have a grand total of 12 hours to work in the finishing center. And then we came up with 1.5 for the chairs, plus
You're going to get sick of the word spike this year.
1.3. T is going to be less than or equal to 15 hours. This should be,
You read that?
that should be a chair.
The whole basis of this thought is that
Good.
it does things.
There's our system, and we're graphing our region. Okay, so here's what we did, right? We took our little problem here talking about furniture requiring an hour. A table requires an hour for assembly, and 1.3 in the finishing center, and then a chair is an hour and a half for assembly, and then an hour and a half for the finishing center. But we only get 12 hours a day for assembly and 15 for the finishing center. So what we did, right, we said, well, let's let x equal table, let's let y equal chairs, and we came up with some inequalities together. Some of you might have you might have your graph reversed, but I want to talk about what this region represents, okay? So what am I looking at inside this region? What are your thoughts on that? What does this mean? And by the way, there are two other inequalities at play here. What are they? Do you see them?
Well, it's x is greater than or equal
Yeah.
to 0 and x is greater than
Yeah,
or
so
y is greater
y is greater than or equal to 0 and x is greater than or equal to 0 because you can't assemble negative chairs and you can't assemble negative tables, theoretically speaking, okay? Or practically speaking, I suppose. So in that case, my question is, what does this region represent?
The combinations of
What do you think, Lauren?
tables.
Is it well, the verses are like the highest possible, like the best possible solutions, like the highest efficiency? And
Yeah, okay, so how do we know which one's most efficient, though? Is that an easy question to answer?
Well, it depends what you're going for. More tables or more.
Depends on what you're going for, right? If we have maybe dollar signs associated with these, it make some sense. But for example, right, if I was going to create, so the way I have it, I have tables here and I have chairs here. If I was going to assemble 5 tables, right? If I'm going to assemble 5 tables, then what's the most amount of chairs I could assemble in a day as well?
You could assemble like 4.
Yeah, so here, let's look at here, maybe I can make it a little bigger, right?
Tables.
So look, if I want 5 chairs, right, then what's the most amount of tables I could create? 4, right? Yeah, actually finish it would be 4, right? Okay, what if I wanted 9 tables?
Only finish like 1.
Then I can only finish 1, maybe 2 chairs, right? Okay, 1.5, right?
No, read just it's not
Is it 2?
yes.
Looks like exactly 2 right there. Okay, so this region gives you your feasible region of what you could work with, right? So you have a lot of options. Each point inside of here will tell you the appropriate, if you want to produce a certain number of chairs, right? If we read the graph the other way, if I want to make 6 chairs, right, then how many tables can I make? If I'm making 6 chairs, how many tables am I going to be able to make? 2, 3, right around there, right? No more than 3. Okay, so this tells you, depending on what you want to look at, tables versus chairs, how many you can make given these constraints. Okay, that's the goal. Just what's the region? What's the solution region? Is it making sense to you guys? Okay, good. Here's the next one I'd like to talk about. Here we go. It's the shipping problem, okay? So right now, this is the fourth box. Let's read it quietly to yourself, and then we're going to do the same type of analysis, right? So we've talked about it, and we're going to define some variables, right? So we're going to say what? Let's let, what do you guys want to be?
Stone BG.
Stone BG.
Let's let stone equal G.
No, S.
S, okay, good, yeah. And let's let what? Gravel, okay. Is that what we want to do? Gravel is going to be G. Okay, good. So what do we know about stone and gravel?
The weight. So like stone weighs 55 pounds.
Yep, so 55 pounds for every bag of stone.
No, sorry, gravel was 55.
Oh, okay. So gravel. So it's important to get it right. Okay. All right. So 55 pounds for my gravel, right? Plus, what else do I know? 70 pounds for every bag of stone. Has to be less than or equal to what?
750,000.
7,500. Good. Okay. What else do I have to know? How many? I need at least how many bags for gravel? So G has to be greater than or equal to what? 50. Very good. S has to be greater than or equal to what? 40. Very good. So we have some constraints here, right? This right here represents our system, okay? So what I'd like you to do is I'd like you to graph this system on your calculators and then transfer the sketch to your graph paper and come up with the solution region for it, okay? So did you guys come up with something that looks similar to this? Something close to this? So my question then is, where is the region then in my graph? Where would it be? Where is the region?
That triangle.
Yeah, it's this little triangle right inside here, right? This is my solution region here, right? So I've got X is labeling as gravel and Y is the stone. So let's talk about, we had a couple of test points up there, right? We said at 65, so here's 65. Check it out, we can go all the way up to 55 bags for sure, at least of stone, right? So this represents our region that we're talking about, right? Each of these points on the end here would represent vertices of our region, okay? And those vertices play an important role in terms of production, about what we can do, what we can't do. So the region defined by these inequalities fit the problem for this constraint of what we have, okay? Do you guys come up with anything different?